All right, welcome. Today, we're going to be detectives. And we're not just solving any old case, we're tackling the biggest mystery of them all, the story of our entire universe. We're going to follow the clues, piece together the evidence left behind over billions of years, and try to figure out how everything came to be. So, let's start the investigation.
So how in the world do you even start to uncover a story that big? Well, like any great detective story, it all starts with a few key clues, a few major breakthroughs. We're going to follow the trail of some brilliant minds who followed the evidence wherever it led, even when it pointed to ideas that seemed, well, completely nuts. Okay, so the first rule of any investigation: know where you are. And for humanity, this was a huge problem for a long time. We had our cosmic address totally wrong. And that one simple mistake was holding us back from seeing the real story. We had to figure out our actual place in the cosmos. You know, for literally thousands of years, everybody just knew that Earth was the center of everything. The sun, the planets, all the stars, they all revolved around us. That was the Ptolemaic model. But then, a totally radical idea came along, the heliocentric model, which put the sun at the center. Now, this wasn't just a tiny little update. It was like tearing up the entire map of reality and starting over. And this massive shift gave us our first huge clue, what we call the Copernican principle. And it's a really profound idea when you think about it. It basically says, we're not special. Earth is just another planet, orbiting a pretty average star in a totally normal galaxy. Once we got over ourselves and realized we weren't the center of the universe, we were finally free to actually start understanding it. So, once we finally knew where we were, we could start really looking out into deep space. And what we started to see was, well, it was weird. There was this mysterious clue hidden in the light coming from the farthest corners of the universe.
Imagine you're standing on a hill at night, looking down at a city, and almost every single streetlight has this strange red tint to it. That's pretty much what astronomers were seeing when they looked at distant galaxies. The light was stretched. It was redder than it was supposed to be. Something was pulling it as it traveled through space. But what?
There's a name for this. It's called redshift. And you've actually experienced something like it. You know how an ambulance siren sounds higher as it comes towards you and then drops in pitch as it speeds away? That's the Doppler effect for sound. Well, redshift is the Doppler effect for light. And it was the unmistakable evidence that nearly every galaxy was rushing away from us. The universe wasn't just sitting there, it was growing. And this is where the logic just takes over. I mean, think about it. If everything is flying apart right now, what happens if you rewind the tape? If you run the cosmic movie backwards, everything has to get closer and closer and closer, all coming together to one single point. And that simple, logical thought leads us right to the doorstep of the most famous, maybe the most mind-blowing theory in all of science. The idea that everything, our entire universe, came from a single, unimaginably hot and dense beginning. It's called the Big Bang Theory. The idea that our universe, all of space, all of time, every bit of matter and energy, burst into existence about 13.8 billion years ago. And it's so important to get this right. It wasn't an explosion in space, like a bomb going off. It was the explosion of space itself. But you know, a theory this wild needs more than just logic. It needs cold, hard proof. And what a smoking gun it turned out to be. See, if the universe started as this super hot fireball, then there should be some leftover heat, right? A faint glow still filling all of space. For years, it was just a prediction, until a couple of scientists stumbled on it completely by accident. This is it. This is a smoking gun, the cosmic microwave background radiation. It looks like a weird, splotchy map, but what you're seeing is the oldest light in the universe. It's the literal afterglow from the Big Bang, stretched and cooled over 13.8 billion years until it's just a few degrees above absolute zero. This is probably the single most important piece of evidence we have for how it all began. So, case closed, investigation over, right? We figured it out. Well, not so fast. Because just when we thought we had the story figured out, we realized we were only looking at a tiny piece of the puzzle. There were other suspects hiding in the shadows.
Not even close. It turns out that everything we can see, every star, every galaxy, you, me, this planet, all of it makes up less than 5% of what's actually out there. 5%. The rest is a complete and utter mystery. The first clue that something was missing came from watching galaxies spin. They were rotating way, way too fast. I mean, so fast that based on the gravity of the stars we could see, they should have just ripped themselves apart and flown off into space. Something else had to be there, something invisible, providing all this extra gravity.
Scientists gave this mystery stuff a pretty cool name: dark matter. We can't see it, we can't touch it, but we know it's there because we can see its gravity bending space all over the universe. It's like the invisible scaffolding that the whole cosmos is built on. We're still trying to figure out what it is, and there are labs all over the world in a massive race to be the first to find it.
But that wasn't even the biggest surprise. The plot just kept getting thicker. Astronomers were trying to measure how much the expansion of the universe was slowing down, and they found the exact opposite. It's not slowing down at all. It's speeding up. Something is actively pushing everything apart, faster and faster every second.
This new mystery force got an equally mysterious name: dark energy. And get this, it seems to make up almost 70% of the entire universe. It acts like a kind of anti-gravity, stretching the very fabric of space-time itself. We have basically no idea what it is. It's the single biggest mystery in all of physics today.
Okay, so our investigation has taken us from the very big, the entire universe, to the very mysterious. Now let's go to the most extreme. Let's look at places where gravity gets so ridiculously strong that it completely breaks the rules of physics as we know them.
We're talking about black holes. They're what's left over when a truly giant star dies and collapses under its own weight. Its gravity becomes so powerful, so intense, that it creates a literal point of no return. Nothing, not a planet, not a star, not even light itself, can escape its grip.
So what's going on inside one? Well, our best theories tell us that all the stuff that falls in gets squashed down into a single point with infinite density. We call it a singularity. And it's a place where our physics just stops working. Space and time, as we understand them, completely break down.
That point of no return I mentioned? It has a name: the event horizon. It's not like a solid wall you could touch. It's more like the edge of a cosmic waterfall. Once you drift past that edge, there is absolutely no way back. The current of gravity is just too strong, and it's a one-way trip to the center.
And this leads us to one of the biggest head-scratchers in all of physics: the information paradox. See, there's a fundamental rule that says information can't ever be truly destroyed. But if you throw a book into a black hole, what happens to the information in that book? The words, the story? Is it just gone forever? Erased from the universe? Physicists are still battling it out over this one.
So you see, our cosmic detective story is far from over. In fact, it feels like we've just scratched the surface. We found these incredible clues: the echo of the Big Bang, the ghosts of dark matter and dark energy. But it seems like every answer just opens up a dozen new, even bigger questions. It really makes you wonder, what other massive clues are just waiting for us out there, hiding in the dark?